Okay, for the Unit 11, Lessons 2 and 3 review, numbers 1 and 2 says choose the most efficient way to solve the following system of equations. Write the method you choose on the line provided. When I look at number 1, what I notice is that I have the same variable with the same leading coefficient, but opposite signs. We have a negative 1y and a plus 1y. All we would need to do is add the two, and we would have elimination. Elimination would be the easiest method, or I should say most efficient method. Number 2, when you look at the equations in number 2, notice that an x is isolated. So we can substitute 24 minus 5y in for x in the second equation. So substitution would be the most efficient method because a variable is already isolated. Number 3, write true or false and justify your answer using a complete sentence. It says one way to start solving the following systems of equations would be to multiply the bottom equation by 2. Well, if I multiply this equation by 2, I would have 16x minus 24y equals 80. That will not eliminate one of the variables. So I'm going to say false. We could say instead, notice if we multiplied the first equation by 2, we would have a plus 12y. So I'm going to say false. The first equation should be multiplied by 2 instead of the second. Okay, and number 4, same thing, true or false. It says that one way to start solving the following systems of equations would be to multiply the top equation by 3. If we multiply this one by 3, we would get 3x minus 3y equals 2. And it looks like we end up with a negative 3 and a plus 3, so elimination would work. So I'm going to say true. By multiplying the first equation by 3, it produces a negative 3y, which will cancel with the plus 3y in the second equation to eliminate the y variable. Okay, so by multiplying the first equation by 3, it produces a 3y, which cancels with the plus 3y in the second equation to eliminate the y variable. Okay, numbers 5 and 6. It says, if the linear system has infinitely many solutions, meaning one single line, identify what value of k must be in the second equation. So what happens is that we want to make sure that these two end up being the same. So 24 to 4, 60 to k, 72 to 12. A pattern here is we could divide by 6. 24 divided by 6 would be 4. 60 divided by 6 would be 10. So k would need to be 10. This way, these equations end up being multiples of each other. So to get this equation to equal this one, what could we multiply it by? we can multiply by 3. Okay, 3 times 5 would be 15. Then 3 times what value for k will equal, actually, negative 27. And that would be k equaling negative 9.